Right, here we are rounding the industrial unit, leaning on the frames of number one, and we've got a new railway character for you to meet today. This is Mr. Bob Millard, who is a very talented fitter, machinist, lots of experience, and did his apprenticeship for British Rail, Southern Region. Didn't you, Bob?
Never mind, but I've learned a lot since then.
What have you been up to on number one then?
Right, basically,
what can you teach us?
Number one, as everybody knows, is up for a 10-year overhaul. And we stripped it all down, we just started on things, and of course COVID hit, so we had like an 18-month quiet period on the job, so we're back onto it now. This is the main frames. The cylinders of the loco sit here. Obviously the wheels go here, and you've got the trailer truck back there. So the boiler firebox drops into there, and the smoke box is up here. Obviously a lot of you will know that, but what we've done, you start with the root of the engine, which is the driving axles. They have to be square and they have to be nice and a good firm fit in their axle boxes, because otherwise you hear engines clanking and banging. That's because the axle boxes that fit into here, and we'll see some axle boxes later on a machine, they get rattly, they wear, and they just basically beat themselves to death, and the whole engine then just vibrates and shakes itself to pieces. So one of the big jobs we're doing here mechanically is to take all that wear out and get it all good again. So what we've done is each of these are called the horns, these angle plates here, they're actually a sliding face, and the axle box slips up and down inside it. It has to go up and down inside it because it needs to have some springing. That's what these are. There's a rod comes up here, and this just works like your spring. So when it goes over a bump, it allows the engine to ride over the bumps, and not that there's many on our track, but that's what they're for.
Don't tell Mr. Palmer that. No.
So it's important that they can slide and don't bind, because if one of those stuck in the horns, it would cause a derailment. But also you want them to be a nice smooth fit. And what I've done, I've hand ground these with a special gauge, with like a big bar that goes in there, and we've ground them parallel to one another to within about 0.02 of an inch, which is about 0.05 of a mil, put it in German. And so that's a nice positive known dimension. Then we put straight edges through here, dead parallel on those faces and on these faces, and we've measured with a micrometer. And that gives us these dimensions here. So you can see that. Basically, we found out what the actual sizes are from that face to that face. Now, it should be 4 foot, 48 inches. And all the motion that was done at Boston Lodge is exactly that. So we have to adjust how we machine the axle boxes to make sure that when the wheels go in the frames, they're exactly 48 inches between the centres. Otherwise, when you put the rods on, which of course are quartered at 90 degrees, it will lock up. What normally happens is you manage to beat the rods on, then they just smash their bearings up fairly quick. So what we've extrapolated from, that's a good word, isn't it?
Extrapolate. A bit of a long word for this.
What we've figured out is, I don't know if you can see here, but each opening, we've shown how we've machined the axle boxes, and the centre line of the axle is still in the middle of the axle box, but to offset the irregularities, that one there is 3.3 from the centre line to that face, but 3.31, that's in thousandths of an inch that way. So that's the maths that we've had to work out once we've got our square faces.
It's adding and subtracting, really, isn't it?
It's not rocket science. If I can do it, it's not difficult. So basically, what we've done is we've trued the engine up. If you don't get the axle boxes and the engine square and true to start with, you're wasting your time. I've seen it when people have restored industrial tank engines. They've done all the rods on the outside but not done the boxes, and as soon as it moves, it all beats itself to death. So that's what we're doing here. The cylinders, that's obviously going here, they are the cylinders that were made by Gibbons in 1957 when they did the rebuild. And they were fabricated from steel, which isn't ideal, but that's what we've got. They've gone away to be lined down with cast iron liners, because when they did her, they rebuilt her at the old worn out sizes. So what we're doing is, because she's now a much higher boiler pressure, because when they went air brakes, they increased the boiler pressures. So she's therefore got a lot more power pushing her pistons. She doesn't need such a big piston. So she's getting 7.5 inch now as opposed to 8 and 5/8. And that's the way Robert Frost Engineering is doing that, isn't it?
So that means you can bore them out in the future.
Yeah, also long term, number 2 and number 1 could probably do a new cylinders casting, so there's a pattern requires making. Nice little fundraising project for someone. And that would mean we can experiment with this, and we know that when we make the pattern, we can actually make the boards a bit smaller. You know, because number 2, the same. She was a 120 psi engine, now she's 160, is it? Yeah. So that's a way being done. That should come back fairly soon. There's new fitted bolts to go in there. The bolts to hold a cylinder on have got to be really tight. Otherwise, the cylinders, a steam engine, from the minute it moves, is trying to destroy itself because it's doing that. So if you can make everything as tight as you can, it helps your case. So these will actually have a whole ream through and the bolts driven in, tight fit. That we've got them roughed out, haven't we, ready for final turning. Likewise, the horn stays here. The bolts in those are rattly, and they're having new bolts. Because when you put the weight on an engine, especially with what is a very delicate frame like this one, especially originally, the frames try and splay. So your axle boxes then flop about. So these stays at the bottom. It's important that they're properly and they're tight. So we're putting new fitted bolts in them. Right, at the back end, the brake gear was a bit of a curate's egg, good in parts,
That's
shall we
very
say.
diplomatic of you.
Yeah,
Bob.
well, I don't like to use expletives or be derogatory about
Well, not
things.
when you're on film, you don't. No.
You know me, I'm just a quiet, unassuming sort of chap. But Martin Turner, who's like our engineering guru, he's come up with, put our heads together, and we've come up with a far improved version of the brake gear. Because what was happening, the steam brake was this side, and the handbrake is this side, one of the few original parts on the engine, funny enough. And effectively, the handbrake only put the brake blocks on this side, and the steam brake only put the brakes on that side. So we've come up with a plan to much improve that, so that all the brake blocks come on.
There'd be a central pull on the cross shaft.
Yeah, but that's all in hand. So once that's done, and the axle boxes are finished, she can go back on her wheels. But in the meantime, obviously the painters can get in here and give her a touch of paint.
Brilliant.
Right, here we're back in the main workshops, the old 1865 Pendray Works, which has never been touched since then. And this is one of her wheel sets. Now, the actual wheel centres, as far as we know, are the original wheel centres supplied new with Talathlin when she was delivered from Fletcher Jennings. One of the few bits on her that's still original. So we've got a lathe here that was big enough to get the wheels in with a bit of modification. So we've turned the profile using a nice hydraulic copying attachment that our young Zach put on for us. These are on their last turn. Next time they're going to want new tyres. The eccentrics here, which drive the valves, they've been gapped. What you don't want is them too tight, because eccentrics have a habit of gripping, then they just destroy the whole of the valve gear. And what we have done differently is we've machined this, which is the back of the wheel, the thrust face. It's obviously got grease on it to stop it rusting. There's an idea of how long ago we turned them, pre-COVID, because the wheels are rusty. But these thrust faces are to control the side float of the wheels. So otherwise, if the engine can wiggle, then it's going to do all sorts of strange things. And prior to that, this didn't have a lot of side control on it. It used the back of the actual radius, which is a very unusual way of doing it. So we've had some new thrust faces manufactured out of bronze, and we'll talk about them a bit in a minute. So that we're hoping it will make the engine tighter and less likely to waggle up the line. So these have been machined. These are ready to go on the engine once the axle boxes are finished, and so is the front pair. And we've turned all the wheels, haven't we? And the trailings, they've all been done. They're over North Shed. So yeah, that's the axles and the wheels. Here we are. These are the actual axle boxes. Remember we spoke about the bits that slide up and down in the horns on the engine. Well, these have been put up and machined on the face here, and a liner. This is gauge plate, which is a fairly hard sort of steel. So these liners have been fitted using bronze screws. You use bronze screws because in the unlikely event of one unscrewing, it won't destroy the iron horn. We'd use a steel screw; it would just chew the horn up. So it's a safety thing. And here are the oil ways that take oil from the crown of the box to lubricate the horn faces. So this is where we've adjusted for all these offsets, so that the actual centres of these boxes now are bang on the middle. There's one side might be slightly thicker than the other, but the important bit is this centre dimension. Then you get the bronze crown, which you melt white metal into. That's a hot works process, which we can't really show on the camera. There's those kids at the front door again.
Yeah, you go out, there's nobody there.
That's right. And then the train turns up, doesn't it? It's bizarre. It's all every time. Right, so these, just to give you an idea how it all goes together, these drop into here. Maybe the other way around. Normally, this has been machined. This would be all very rough cast. Then this is the keep, and that has an oil reservoir in it, which is full of horsehair. So that keeps the oil going up underneath the journal. That goes in the top. And that holds it all together. And then there's a couple of pins. I won't bother putting them in now, but they go through there, hold it together. Then that goes up the other way and is now on the engine, and the axle for the engine now goes in here, and the wheel's sat here. Now, when you white metal axle boxes, so the only thing that's taking the weight is the top half of the hole. The bottom half of the hole is in fresh air. And so we need to machine that. And just to give you a little idea, with white metal, if you've got your axle, the bearing only comes to here. As you're saying at the bottom, not the top. Don't worry about that. What you don't want is the bearing touching here and here and a clearance there, because what it does, it scrapes the oil off the steel, and the bearing, then the metal gets hot and it runs hot and melts. So when you do a bearing for an axle, unlike a precision roller bearing, you have it touching here and you actually exaggerate it, have a gap there. So the axle only touches here. We're only talking 0.005 of an inch, what's that, 0.1 of a mil. How much was it? 0.127. There, I think it was the P. I've got a youngster here that can read and write and all that sort of thing to help me. So it's important when we bore the axle boxes for a steam engine, you have to allow a bit of oversize, and that's what we're just about to do here. And the way we measure it, because it's very hard to measure half a circle. If you've got a complete circle, you can put an internal mic in, but to measure half a circle, it's a problem. So what we do, we make these. These are dummy axles. These are machined, these rings, to the same diameter of the actual journal on the wheels. And this one here I made earlier has been fitted so it exactly fits that axle now. There's no rock on it at all. That diameter is perfect to the journal, okay? But that's no good because the oil can't get past it. As the oil went round, it would just scrape it off. So what we do now, we take a slightly bigger cut to give that clearance. So we put the, this is a lovely little boring machine. In fact, if I wasn't married, I'd probably ask it to marry me. It's a beautiful bit of kit. We'll zero that off there. I believe Mr. John Bate bought this for the railway many years ago, so I'm led to believe. Yeah, paid for himself. Yes. So what we do now, that dial is in thousandths of an inch, so I'm going to move that 0.005 of an inch. There are 5 divisions on the dial. That is now set to cut the final cut. So we're going to put that on a bit of noise. That tool's flading round, we'll put the feed on, and that will now cut through the box a very small amount. See it cutting? Obviously you don't want to go putting your hand too close to that sort of thing, and that's how we machine an axle box. And it's all that work from setting up the frames, machining these faces. It's probably 2 or 3 weeks work to get to this point, but that's now, the bearing is now ready to go onto the axle. I'll stop it now because we can let that finish in a minute. Now, the one thing left, I spoke about thrust faces. I believe my glamorous young assistant has got one that he made earlier. This is it's young Mr. Parrott, who runs Model Engineering Laser, really useful company, bearing in mind. He's made these. These are out of bronze. They won't cheat because it's proper bearing grade bronze. And these are going to be fitted on the other side of the box there. And that's what that face that I machined on the back of the wheel will bear against. And that will give the side control so that instead of it going down the track and the wheels doing that, it will actually ride nice and steady, which will help improve our riding. And the next job on here is to fit these and machine them to the exact dimension. I didn't bring my clipboard back, but the clipboard's got, I've had these in the axle, in the engine, and I've measured from one side to the other accurately, so we know exactly what thickness to calculate these to be. And that basically is all there is to it. So now you all know how to do axle boxes.
Right, well thanks Bob for explaining all that. I think setting up axle boxes and horn guides is a bit of a black art, it's very specialised. But that little explanation hopefully has dispelled a little bit of the mystery.
Yeah, I've just been very lucky over the years to get the experience of the right places to pick this up. It's, you know, it's just being in the right place at the right time. You know, I've done a lot of axle boxes for various people. We did number 4, didn't we? All new boxes. Then we've done number 7. So yeah, it's coming on.
All right, cheers Bob, thanks for coming.